One of the things that comes up often when you are discussing titrations is the idea of what is called a buffer solution. And a buffer solution is, if you remember when we talked about doing a titration, that I drew a little picture here that had, I believe it had 10 or so HA molecules in it. So there's 4, 5, 6, 7, 8, 9, 10. Okay, so you start with an acidic solution. You slowly start to add some base. So remember, you got HA plus a strong base, OH minus, making H2O and A minus. But remember, you've got a lot more of this. So as you slowly start to add that in, as you start to come the OH minus ions, they react. And so you're never going to see any OH ions in there, because as soon as you put them in there, they're going to react and they're gone. Okay, which means that, again, you're going to be left with some of this and this. So as you add that hydroxide, again, little by little, these HAs will react with those OH minuses. Remember, this is in water. And they start to produce the conjugate base, okay, the A minus. And then as you add more A minus, more and more of those acid particles turn into the conjugate base. Okay, we keep going and going and going until we reach this point right here, where notice that half of the acid particles are gone and they've been replaced with A minus ions, with the conjugate base. And if you remember correctly, that when that point occurs, you have reached what's called the half equivalence point. Okay, right now you are at the half equivalence point if you're doing a titration. Okay, and at this point, you know, if you remember correctly, again, in that pH curve, it's pretty flat in here. Okay, and because the half equivalence point is right about here, again, roughly. Okay, the reason that it's pretty flat in through there is because at this point right now, where you have half acid molecules and half conjugate base particles, you have created what's called a buffer solution. Okay, and a buffer solution is one that when you add some strong acid or some strong base to it, it resists a drastic change in the pH. Okay, so a buffer solution is a solution that the pH doesn't change very much, if at all, when you add some acid or some base to it. And the reason that it doesn't change very much, and you can see it right here, this whole region right here inside that rectangle, that's all what we would call the buffer region. Okay, because once you start to create a buffer solution, again, that pH isn't going to change very much. Okay, now why not? Why does the pH not change? If I add some more acid to this solution, or if I add some more base to the solution, the pH is not going to change very much. And the reason is because right now, again, our buffer solution here is made up of half of an acid component and half of a conjugate base component. And so when you add some acid, what's it going to react with? Well, of course, an acid is always going to react with a base. Okay, so if I add some acid, what's that acid going to do? It's going to react with these conjugate base particles that we have in here. Or if I add some base, what's the base going to react with? Of course, it's going to react with the acid particles. Okay, and so anytime you add an acid or a base to a buffer solution, of course, all of that acid and all of that base gets used up until you reach what's called the buffer capacity. But basically, it's going to get used up until either all of that acid or all of that base is gone, and then you're going to see a drastic change in the pH. Okay? So buffers are solutions that contain half of it is an acid component and half of it is a base component, okay? And it does need to be a weak acid. Obviously, if it's a strong acid, there are no acid particles. All of that acid will break apart into H plus and A minus. Okay, it has to contain a weak acid and its conjugate base, or it can contain a weak base and its conjugate acid. Either one of those two will work. Okay, so what happens? Let's actually look at what happens here. Let's say you have a buffer solution, and again, these obviously HA isn't a real acid and A minus isn't real. But let's say you have a real buffer solution. So let's say again, let's change our buffer here to an acetic acid buffer solution. Okay, and I'm not going to draw 10 of them because I just don't want to waste your time. But here you can see it. Remember we talked about carboxylic acid. See how that ends in COOH? Okay, so we've got CH3COOH. And then again, I'll just draw, how about I draw 3 of each of them? COOH and CH3COOH. Okay, so there's our acid component of the buffer. And then the base component of the buffer is when the hydrogen is gone. So it's just CH3COO minus, CH3COO minus, and CH3COO minus. Okay, let's say we've got that many in there. So we've got 3 acid particles and 3 conjugate base particles. If I add some base to that solution, so I'm going to add some NaOH or KOH, or basically some soluble hydroxide compound, that OH minus is going to react. And again, you've only got 2 choices. Is it going to react with the base, or it's going to react with the acid? Well, if you add a base doesn't react with the base. A base reacts with the acid. So here you can see it. What happens is the base that you've added will react with the acid component. And what will it do? Well, what do bases always do? They accept the hydrogen. Okay? So the base is going to take that hydrogen off of there. And again, what you can see, all that's happening here is this acid particle that we have is now just turning into the conjugate base. So basically, when you add a base, what happens is this, is the acids start to turn into conjugate bases. But again, that doesn't affect the pH, right? All of the hydroxides you're adding, you're like, well, you're adding a base. Of course, the pH is going to go up. Only if the hydroxide ions stay. If the hydroxide ions react with something and they're gone, then the pH doesn't go up. Okay? And eventually you'll get to a point where now all of these acids have now turned to conjugate bases. And now we've reached the buffer capacity where there's no more acid for it to react with. And so now if you add some more hydroxide, of course, what's going to happen? They're going to have a bunch of hydroxides floating around in here now. And now, of course, the pH is going to go screaming up. Okay? But again, that you have to get rid of all of those other particles, all of those acid particles first. All right, so let's go back to our buffer solution again here. So here's our buffer solution. We've got acids, we've got bases. Okay, what happens if you add some acid? So I'm going to add some HCl or some HNO3 or any of the 7 strong acids that you've learned about. When you add a strong acid, what are you really adding? You're really adding H+, okay, or H3O+, okay, as you can see down here. Okay, and so what does that acid react with? So now I'm going to add some H+ to this solution. Of course, what is it going to react with? What do all acids react with? Of course, the bases, okay? And so as you can see, what happens here is the H+ that's in here is going to go to here and reform those acid particles. Okay, so instead of these becoming bases, like in the previous example, the bases are now going to become acid particles. Okay, and then this one, you keep adding some more hydrogen ions, you form more acid, and then you add some more hydrogen ions, and then this one becomes an acid as well. Okay, and then all of a sudden you're just left with the molecular form of that weak acid. And then again, if I keep adding more hydrogen ions, now I start to build up the hydrogen ions. I've reached the buffer capacity, and the pH is now, of course, going to go down. Okay, However, we're not worried about once we reach that capacity. We're worried about, what buffers do to keep this pH relatively flat is, again, if you add an acid to a buffer solution, it reacts with the conjugate base, as seen right here. The acid is reacting with the conjugate base to reform the weak acid molecules. Okay, and when you add a base to a buffer solution, it's going to react with the acid component to form more of the conjugate base. So you're either forming more of the acid or more of the conjugate base until all of those particles are gone and that the buffer capacity has been reached. Okay, so, and again, notice how much I reference titrations in this process. Okay, titrations are going to keep coming back quite a bit as we continue our discussion of buffer solutions. So that's what a buffer solution is. A buffer solution, the best buffer solution you can form is a buffer solution that has half weak acid particles and half its conjugate base. Okay, or a weak base and its conjugate acid, and half of it is its conjugate acid. Okay, and then you've got the maximum amount, you've got enough of both of them to be able to resist that drastic change in pH that you see right here. Okay, like in real life, your blood is a very, very good buffer solution. And that's why when you do stupid things, like you drink things or maybe use things that aren't good for your blood does a very good job of not reacting drastically to that, because your blood is a buffer solution that doesn't allow the pH to change drastically inside of it very, very quickly. So, how do you make a buffer solution? Well, we just saw one. When you do a titration and you get to the half equivalence point, you have created a buffer solution. So, let's see, is that this one? Yes, this one right here. So if a weak acid has a strong base added to it, notice the amounts here are really, really important. If you have 50 milliliters of a 0.5 molar solution of a weak acid and you add 25 milliliters of base to it, notice that still leaves basically half of the moles of the acid to react with. Okay, notice that since the volume of the hydroxide is much smaller than the acid, certainly the hydroxide is the limiting reactant and it's going to run out. And what are you left with? You're left with a large concentration of this and a large concentration of this. You have a small amount of H+, but really in a buffer solution, you have a very, very large concentration of the weak acid and a large concentration of that weak base. And now basically what you have is you have this without those extra hydrogens in there. Basically now you have this, where now you have, again, let's go back to where you have half of them are acid particles and half of them are conjugate base particles. Okay, so a titration where you add just enough base to react with half of the acid, that's one great way to form a buffer solution. Okay, and a lot of times you'll see the term, it's an ideal buffer solution, because when those two concentrations are equal to each other, okay, that's when your capacity is going to be the greatest. If you have more of the acid or more of the base, then your capacity in one direction isn't as high. Okay, the other way you can form a buffer solution is simply by taking a weak acid or a weak base and adding something that's soluble that has the conjugate base already in it. Okay, if you have 50 milliliters of a 0.5 molar solution of acetic acid, so again, right now, all you have is that acetic acid. And remember, there's two different ways to write it. Remember that that's the same as CH3COOH. Sometimes it's easier to write it that way. Okay, and then, so I've got a solution that's only got acetic acid in it, but now I'm just going to add some NaC2H3O2. Okay, when of course it's got a sodium in it, so it's going to be soluble, which means now I'm going to have a bunch of Na plus ions floating around in there, which we don't really care about. But more importantly, we're going to have C2H3O2 minus, which is the conjugate base. Okay? And notice in this case, notice that they add the same. If the concentrations are the same, then the volume, notice they add the same volume. It should say 15 milliliters of 0.5 molar sodium acetate. Because then notice you're adding the exact same number of moles of the acid. You're adding the exact same moles of the conjugate base. And again, you've created another ideal buffer solution. Okay? Now, again, most of the time we talk about weak acids and then adding a conjugate base to it. Okay, but this can also happen obviously with weak bases. Okay, if you have NH3, it's going to form an equilibrium with NH4 plus and OH minus. Okay, but because it's a weak base, you get very little of the NH4 plus and the OH minus. But if you add, again, enough strong acid to react with it, it'll react with that NH3 and form NH4 plus. So then again, you can have a buffer solution that has some NH3 in it and some NH4 plus in it. Okay, or you can take some, so remember, that's one where you would add half as much. You would add enough acid so that half of that NH3 reacts and turns to NH4 plus. Okay, so it'd be NH3 reacting with that acid to form NH4 plus. And again, you can't add too much H plus because then all of that NH3 is going to react. You need the NH3 and the NH4 plus for it to be a buffer solution. Or, just like with the acid up there, you can have a solution of NH3 and then you can just add a solution that has some of the conjugate or some of the conjugate acid in it. So if you had like some NH4Cl, of course, ammoniums are soluble, so that's going to break apart, and you're adding NH4 plus. And just like with the Na plus above, you're also adding Cl minus. But again, that doesn't really do anything. So again, now we've created a buffer that has some NH3 in it, and it has NH4 plus in it. Okay, the key to forming that buffer solution is when you're going to react the acid to form the conjugate base, you have to only use, again, half that same amount or half the number of moles so that you still have some acid left over. Okay, when you're going to combine, just take some weak acid and then add something that already has the conjugate base in it, then notice you add the same amount of moles to both. Okay, same volume, same concentration to get the same amount of ions as you do acid particles. Okay, so buffers are they're really, really important, and that was a lot of information about buffers. Maybe a good idea to go back over go over this video again, just to clarify a few things, but there's some really, really important information in here about, number one, how do buffers keep the pH from jumping very much, right there, okay, and then number two, what are the two different ways that you form buffers? Okay, that's also really, really important information that's going to come back a lot as we continue talking about titrations and buffer solutions.